So in this problem here, we know that -1, 4 refers to here, which is -1, 4 on here, and b is -3, 0. And the way to approach this problem is kind of unconventional, because you actually think about this in terms of vectors, or I do at least. I know that if I go to here, this is actually going to be going to go up 4 and over 2. So it's really following the vector 2, 2, 4 up in that direction. And so if I am going to go here, if I know it's a square, I know these are all perpendicular. So that means this is going to go exactly opposite. It's going to go 4 right. It's going to go in the vector 4, -2, and then down 2. So if I add these complex numbers together, or the vectors together, this point here is going to be -1 plus 4 is 3, and 4 plus a -2 is 2. That is this point here. Point D is simply going to be, as a complex number, is 3 plus 2i. And so there's not a lot of deep calculation to do. It's just a lot of kind of figuring it out from here. And so similarly, if I go from here, if I'm going to go to C, I can go down 2 over 4. So from here, if I go, oh, I do notice this is backwards. Oh, let me try that again. I do notice that this is backwards. This is 0 minus, no, it's not. Hold on. No, it's not backwards. Okay, so -3, 0. So if I go down, and this is 4, so it's going -3 plus 4 is going to be, this point is going to be 1, and 0 minus 2 is -2. And so z as a complex number will be 1 minus 2i. Similarly, if I would go down 4 from here, that would be -2, and over this way from here, that will be 1. And so it's really just a matter of adding and subtracting vectors that are written in terms of the positive one, also the perpendicular one as well.